everyone, welcome to this C1 booster session on solving quadratics by factorising. Now this is going to be potentially quite a long session, so what I suggest you do is get a pen and paper and just be prepared to pause the video and give the questions a go yourself first before listening to my explanation. Now first we're going to look at just factorising. We're not actually going to solve equations in example 1. It's worth noting that actually all quadratics do factorise. It's just a question of whether they factorise over the integers or not. So let's give this one a go. Now we should know that we're going to get an x here and here. That is so that we get the x squared. That, I suppose, is the easy bit. Next we look at how we can get 40, and I do recommend doing one of these factor tables. 3 is not going to go in 4 and 10, 5 and 8, 6 doesn't go in, 7 no, and 8 we've done that already. All of them will give 40, so we know there's lots of ways to get that, but the question now is which one of these could give 13. Now 1 and 40, we could get 41 from that. If we add or subtract in some way, we could get negative 41, we could get 39. We're never going to get 13 though. We're never going to get 13 here. This one here, we could get 14, maybe. We could get 6, but we're not going to get 13. So of course, we're going to choose 5 and 8. And I've not actually given any consideration to the signs yet. I'm just pretty confident that 5 and 8 will work in some way. I normally look at this sign next. That's telling me that both my signs are going to have to be the same in order to get plus 40. And then I just take a look over here and think, no way could they possibly both be positive. I've got to commit both to being a negative. And now I just check if the thing works, particularly focusing on that. So outer negative 8x, inner negative 5x, which does give me that there. So it's deductive reasoning, really. I don't particularly like it when students say it's trial and error. It's not. There's a reason why you would do what you do. Looking at this one, we're not going to use the algorithmic method, which I'm going to go on to discuss later, because there's really only one combination that would work if this does factorise over the integers, and it's the one here. 5 is prime, so that's the only way that we should be getting the 5x squared. 4 is not terribly divisible. We've got 1 and 4, 2 and 2 as our possibilities. But now what you've got to bear in mind when we are thinking how we're going to get an 8 is one of these numbers is going to get times by 5. So we don't view that as a 1 and 4. We either view it as a 5 and 4 or a 1 and 20. So can 5 and 4 give 8? Somehow, no. Can 20 and 1 somehow give 8? No. So now we move on to here. Don't view it as 2 and 2. We perhaps view it as 10 and 2, because one of them will have to be times by 5. And can 10 and 2 give 8? Well, yes, it can. So put in the 2 there. That's how we've got a 10x. But let's just put both 2's in now. And again, I'm not really worried about the sign yet. I'm going to do that now. First of all, I look here first. That's telling me, in order to get my negative 4, both signs have to be different. So you're going to get to choose one of them to be negative. But look, negative 8x, that really is quite negative. We're going to have to get quite low. So let's position a negative sign there so that we get the big negative 10x. And let's recover that with a plus 2x there to give the negative 8x overall. So inner, we've got 2x. Outer, we've got minus 2x. Again, it's not trial and error. It is deductive reason. There's a reason why you would go down a particular route. So that's factorisation. I'm sorry, there's another factorisation question here, but I'm going to use a different method. And you may not have met this. I do find that some students have not met this. I think it's one of those things that some math teachers go through and some don't. But when you've got a problem like this, the issue really is that that 12 is highly divisible. So it could be a 12x and a 1x bracket, or it could be a 4x and a 3x bracket, and what's the other one? Or a 2x and a 6x bracket. And I don't really have a way of telling immediately what it's going to be. So you could guess wrong, and then you've kind of wasted a bit of an effort. But there is a method that can help us. The problem is it takes a bit of remembering, but this is how it goes. We're going to look for two numbers that when you multiply them, you get A times C. By that I mean the x squared coefficient A and the constant C. So in our case, we get negative 180. The same two numbers we need to add to give the coefficient in the middle, B. So in our case, we've got 8. So applying this to our problem, A times C, 12 times 15, 180. And the fact that it was a positive and a negative is very significant. We're aiming for negative 180. And the number in the middle is 8. So we first turn our attention to here, the timesing. How could we get 180 in terms of two numbers that we're going to times together? And also, these two numbers, bear in mind they do have to add to 8. So I'm not going to really bother with the low ones. I don't see how that's going to give 8. So maybe we should skip a few of them. Perhaps try 5 first. 5 goes into there. Well, 10 goes in 18 times, so 5 would go in 36. So I've tried that one, but I don't see how that's going to add or subtract in some way to give 8. We could get 31, say, or 41, but not 8. So we try something else. Does 6 go in? Well, that goes in 30 times. But maybe that could give 24 or 36, something like that. It's not going to give an 8 when we add or subtract. Does 7 go in? No. Does 8 go in? In fact, no, because if you divide 180 by 2 3 times, you don't get a whole number. 9 goes in. This is promising. It could be 9. That goes in 20 times. But no, that's not going to give 8. It could give 11, say. So let's move to 10. And 10 times 18. I think we have a winner. 10 and 18 could give the 8. So let's just try these. Let's just put them in. Don't worry about the sign yet. And we need it to be a positive 8. But at the moment, we're getting 28. So if you look at that carefully, what we need to do is make that 10 a negative. And then we've got 18 minus 10, which does equal 8. But if you make that a negative, that's got to be a negative. These numbers have got to be the same here and the same here. But indeed, that's good because it does give minus 180. So you can see it's a bit of a long-winded method. That's one problem with it. So we use it as a last resort, really. Now, what this is telling us, it's telling us how to break up our 8x. We're going to write that a rather odd way. We're going to capture the 8x as a 18x minus 10x. We can do that because, frankly, that is 8x. I've not changed anything. I'm perfectly entitled to use the algebraic equivalent sign. But now what we do is we do what's called factorisation by grouping. I'm going to factorise those two terms in a bracket, and separately I'm going to factorise those two terms. And actually you could group any pair of terms you want. I could do those two terms together and those two. Any pair, the actual sort of algorithmic method will work. Okay, but I'm going to factorise those two. So the highest just normal number that goes into 12 and 18 is 6, and then the highest letter that goes into both of them is an x. So that's what I pull out. Now I'm going to open up some brackets. If I've got 6x already, I need to times by a further 2 to give the 12 here, and I need to times by a further x in order to give the x squared there. So there is our 12x squared. And again, if I'm starting with 6x, I need to just times that by 3 in order to give the 18x. Now we're going to factorise over here. You can see that 5 goes into each of them, but we've got the option instead to factorise out a negative 5, which I would recommend because you can see here that in this bracket I only have positive terms, and it will be in our interests to only have positive terms in this bracket as well. So we're going to pull out the negative as well as the 5. And now if you've got negative 5 and you wish to get negative 10, you just times that by 2. But we also need an x there. And if you've got negative 5 and you want negative 15, you simply times by 3, and it's positive 3. Check. The signs are different here, which is why it ends up being a negative. And what's very clever about that method is we have the same bracket here and the same bracket linear factor there. So what we can do is treat this as one term here, and just think of this as another term, and then make the interesting algebraic observation that 2x plus 3 divides into both of these terms. It divides into there and it divides into there. So if you've pulled out a 2x plus 3, if you start there, think, what do I have to times 2x plus 3 by to give me 6x 2x plus 3? And of course I need to times by 6x. And again, if this is our start point, 2x plus 3, what do I have to times it by to give negative 5 times 2x plus 3? Well, of course, a negative 5. And there you go, we've factorised the problem. Now, I think many of you viewing this video will say, okay, fair enough, you've got to the answer, but you really took a long time. And that is true. It's one of the problems with this method, is it does take a very long time. But if, for whatever reason, you get the sense that it does factorise and you're not managing then to actually factorise it, then you could use this method. But perhaps just use it for ones where the number here is, say, highly divisible, and there are many combinations. Moving on to here, now with these types of ones, what I expect you to be able to do is recognise when you've got a number squared minus another number squared, because these always factorise as a minus b, a plus b. We call this the difference of two squares. We can check, there's our a squared, there's our b squared, and the signs were different, so it is a negative. And then if you go to the outer here, we get an ab, and the inner here we get a negative ab, which is why we get nothing in the middle. So when that is the case, it's actually an easy factorisation. We've got a square number here, and we take the square root of it essentially and put it here and here. We've got a square number here, we take the square root of it and put it there and there. and then one of them's a minus, one of them's a positive. Look, we can check this. 4 times 4 gives you your 16, x times x gives you your x squared, and then 7 times 7 gives you your 49, and the signs are different. It's the difference of two squares. Do recognise that algebraic structure when you can. They can be quite sneaky on Core 1. You're really only expected to factorise up to quadratics, but they could sneak a cubic like this on. The reason being is it's not actually that difficult to factorise, because you can observe, first of all, a common factor in all three of those terms. The common factor is, of course, x. You can pull an x out, which is what we do first. So if you've got x and you wish to get 3x squared, you need to times by 3 and then a further x squared. If you start on x and you want to get minus 2x squared, you need to times it by minus 2 and a further x. And if you start with x and you wish to get minus x, we just times by minus 1. So now what we do is we're not finished there. We do need to keep factorising, but we just ignore the x term there. Well, I say ignore it, it will always be there, but we're just going to focus our attention on the quadratic part of what is overall a cubic. So we just, yes, write that again, but it's really out of play now, and we're going to try work now just on this part, which, because we've got a 3x squared there, that will be the only way to achieve that. And then we've just got a 1 there, so the only way to get 1 is a 1 and a 1. So this must somehow work. But now we turn our attention to here. Because that is a negative, my signs here need to be different. The question is, where do I position the negative? Well, given that I need to end up quite negative overall, your one negative that you get, you really want to deploy on the big number, because there we get a negative 3x, which gets us quite low, and then the plus 1 here is us recovering by 1, which will land us overall on a positive 2x. So that's that factorised. Okay, we're going to move now on to solving quadratic equations. We've actually got an equals sign now. When you solve quadratics by factorising, it really relies on the fact that if you've got a times b equaling 0, you can tell me one of two things, or possibly three things. That is to say that either a is 0, b is 0, or perhaps they're both 0. But the point is, what you're looking to do is get your quadratic factorised and get it crucially equaling 0. That's vital. You need to always rearrange what you've got, whatever the quadratic is, so that it equals 0. I can't emphasise that enough. So clearly at the moment we're quite far away from that. So what we want to do first is expand our brackets. And now we're going to aim to get everything onto one side and leave 0 on the other side. So first I could reduce each side by 6x, so I'm going to go downwards. So I've got x squared over here, but I'm going to take off 6x, which lands me on negative 5x. And next we're going to go up by 6 both sides. Now, crucially, we've got it equaling 0, which you must always do. And now we're going to just try and factorise this directly. We need an x there and there. That gives me my x squared there. 6, if we just break 6 down, it could be 1 and 6 or 2 and 3. And this is actually a very popular GCSE and A-level question, because interestingly both of these you could somehow get 5 from there, and you could somehow get 5 from there, but only one of them actually works. The problem is that both the signs will have to be the same, because it's a positive 6 there. So this one will not work, because whilst you can get 5, you get 5, or at least you get negative 5, which is what's there. You would get negative 5 with a minus 6x and a plus 1. But that will not be permitted, because you're not going to get a plus 6x there. So in fact, it's 2 and the 3 that work, because we can have them both being negative, and that will give me my plus 6x, and then outer it will give negative 3x, and the inner here it will give a negative 2x. So you will get your negative 5x. So it does catch people out, that one. So now we're going to use the principle, that is that if you've got a times b equal to 0, either a is 0 or b is 0. So basically either that's 0 or that's 0. Now if that is 0, you can conclude that x equals 2. So that's one solution. And if the other linear factor equals 0, it must be that x is equal to 3. So there are our two solutions to what was a quadratic equation. Moving on to b. Take advantage of the fact that you have an equation. You can, if you wish, just divide both sides of the equation and simplify things down. You should observe that a number that can divide into each of those, namely 2. So first of all, we can divide this side by 2 and this side by 2. So we'll have an x squared minus 25, and don't forget to divide the right hand side by 2. 0 divided by 2 is, well, 0. So the only reason we can do that is, of course, is that we have an equation. If it was just an expression, you couldn't just divide by 2. Crucially, we have an equal sign, which is why we can do that. Next, we have the difference of two squares. As mentioned earlier, they factorise like this. So we'll get x equals 5 or x equals minus 5. Although you could, if you wish, say that add 25 to both sides and then simply square root both sides. You get the same answer either way. Let's move on to C. I put this question on because I wanted to point out the fact that whilst in this question we could divide both sides by 2, you are not permitted here to divide both sides by x. If you do that, then you actually lose a solution. So you mustn't divide both sides by x. What you need to do here is stick to the principle which I mentioned here and get everything equal to 0. So take the 7x from both sides, and now what you are looking to do is factorize this. And interestingly, students find this difficult. The reason is it's actually a very easy factorization, and perhaps we all try and overcomplicate it. There is no normal number, there's no constant at the end here. So it's actually, you just ask yourself, what can you divide into both those terms? What can you factorize out? Of course, you can just pull an x out. So it's one of those simpler factorizations. And do bear in mind that this very much counts just because it's a plain old x. That would be your A, that would be your B, and you're asking yourself, how could you get 0? Well, you could get 0 by x equaling 0, or to make that bracket equal 0, x would have to be positive 7. So don't get caught out by these very easy ones by overcomplicating them. Let's move on to this one. Again, we're going to take big advantage of the fact that we have an equation. We don't like the fact that we've got a negative 4x squared there. It's a bit disconcerting, but fear not, because we can, if we wish, multiply this side of the equation by negative 1, which, well, you can only do if you multiply this side by negative 1. So by multiplying all of that by negative 1, it has the effect of all of the signs changing. So now it's a positive 4x squared, a minus 23x there, and a minus 6. And yes, I suppose technically you need to do 0 times negative 1, but not a lot changes there. So it's become slightly easier because of that. Now, we've got 4 here, so it could be a 4x x factorisation, or alternatively, it could be a 2x 2x factorisation. I'm not sure which one. So perhaps this is another opportunity just to practice our technique of looking for two numbers, which in this case will give negative 24. Don't forget the negative. And sorry, I've missed a space for my number. And the same two numbers must sum to give the x coefficient. So in this case 23, and I think this is going to be a lot easier to work out. Clearly it should be 24 and 1 in some way, because we can imagine that giving 23. It's all a question of where to position the negative. Negative 24 is very flexible. Frankly, it doesn't care where you position your negative. It's just this one here that cares a little bit more, and indeed you want to position your negative on the 24. So you've got negative 24, add 1, which does give that. So that is telling us how to split up our negative 23x, namely into negative 24x add x. Okay, so it's a rather odd way to capture negative 23x, but it does mean that things factorise nicely. So I'm going to group these terms together. You should observe that 4 goes into both of those terms, and in terms of letters, an x goes into each. Let's open up some brackets now. If you begin on 4x, multiplying by a further x will give 4x squared. And if you begin on 4x, then to get up to 24, we need to times by 6. So 4x times 6 is 24x. I now just need to think about the signs. And technically we need to factorise here, but nothing actually factorises out. Well, I say nothing. Of course, 1 actually factorises, but we don't really need to put the 1. I suppose we get that, but don't worry, it does appear to work. We have got what we are hoping to get, the same bracket here. So view this as one term and view this as another term. So x minus 6 goes into both. Now x minus 6 is your start point. Ask yourself, what do you times that by to get that? And then this is your start point. What do you times it by to get that? And actually, because that's the same thing, we would just times by 1. That's a plus 1 there. So that's factorise. So we need to force this bracket to equal 0, in which case x would equal 6. But harder is, how do we make that bracket equal 0? Some of you might recognise the answer straight away, but if not, just think, well, I'll just write a little equation. For what x value do we get 0 there? Minus 1 off of each side. Divide both sides by 4. problem solved. Moving on to this one, again, just to go back, just to keep emphasizing this principle, you've got to make everything equal to 0. So let's expand this out. Okay, 3 times 4, it's not 7 times, please. And get everything equal to 0, so we're going to need to subtract 13x from both sides. So we've got 3x squared, take away 13x plus 12, and that equals 0. And now we try and factorize. We don't really need the algorithmic method, because if this does factorize nicely over the integers, it will do so with a 3x and an x. That gives me my 3x squared there. Now 12, in fact I'm looking at the 12 and the 13, and I was going to go for 12 and 1 straight away, but of course because of the 3, that's going to change things. So I'm not going to rush this, I'm going to just break this down here. It's not going to take long. And don't think that it's going to be this one. I don't think it will be, because one of them has to be multiplied by 3, unfortunately. So we don't view that as 1 and 12, we view it as 3 and 12, or 36 and 1. Looking at this one, you view that as 6 and 6, or 18 and 2. I don't think we're going to get 13 there. We view that as 9 and 4, and actually from 9 and 4, I can see us getting 13. Notice there it was the 3 that was being multiplied by 3. So we need to get the 3's working together. So I suppose the 4 will be positioned there. Now, observing that both signs here will have to be the same in order to achieve the positive there, but here we've got a negative. The only thing that would work is that, and now we check. Outer negative 9x, inner negative 4x, which does achieve the 13x there. So we're now going to force this bit equal to 0. We can just do a little mini equation. So 3x minus 4 equals 0. Add 4 to both sides. Divide both sides by 3. Or x equals 3. Next, really an extension question, really. So this is quite a challenging one. Remember, do pause the video to have a go at the problem yourself first. But again, we're just going to apply the principle of trying to make everything equal to 0. So we're going to expand here. And we actually get minus x to the 4 there. Now I'm a bit concerned about the x to the 4, because this lesson is really about solving quadratics, not polynomials with a power of 4. But nonetheless, let's just keep persevering. I'm going to make this side equaling 0. So we're going to add the x to the 4 to both sides, and we're going to subtract 10x squared from both sides. So now we're going to get a minus 10x squared there. We're going to leave the 9 where it is on the right hand side. They could, if they're being a little bit difficult, ask something like this. Whilst it is not a quadratic equation, it's a power of 4, you will get 4 solutions from this always, not 2. It does nonetheless have a kind of underlying quadratic structure. We can just go ahead and factorize it as we perhaps ordinarily would. The only difference being that in order to get x to the 4, that will not do at all. That gives x squared. But of course, if we have x squared there, then it does achieve the x to the 4 there. Let's just proceed now as normal. We've got 9. 1 and 9 could work, or 3 and 3. but we're aiming for the 10. So I think that this one will work and that one won't. So let's try slotting in 1 and 9. And this is telling me that the signs have to be the same, but then this is telling me that they actually have to be the same and negative. So let's just check that. Again, that's where we've got x to the 4. Outer, we have a negative 9x squared, and inner, we have a negative x squared, which does give me the value there. And then we do also get the 9 there. So we've factorised it, at least partially. We can go further. We have factorised this power of 4 polynomial as a product of two quadratic expressions, two quadratic factors. But we can go further. The first one here is the difference of two squares. So we can factorise there. And the second quadratic expression is also the difference of two squares, so we can factorise this as so. Consequently, we have our 4 solutions. We have x equaling 1 as a possibility, or negative 1, or 3, or negative 3. So really an extension question there. Perhaps unlikely to come up, although they could do something like that. Next, it's not obvious that we have a quadratic here at all. We've got horrible fractions, and that's the first thing that we need to deal with. I really don't like the fact that we have a 3 minus x here and an x plus 2 here. So what we need to do is remove that. To remove the 3 minus x, one would need to multiply both sides by the 3 minus x and multiply this side as well. In addition, if you wished to remove that from the denominator, we'd need to multiply that side also by x plus 2, which you can only do if you multiply the other side by x plus 2. So when you come to multiply this side by 3 minus x, you should be able to see that it cancels with the denominator. So that's fine, that's just going to get cancelled. And when we multiply this side, it's just going to basically sit there. And then when we multiply this side by x plus 2, it's not really going to cancel, so it's just going to stay there. And then when we multiply this side by x plus 2, it's just going to cancel with the thing on the bottom there. So we've got 2x. When we multiply by 3 minus 2x, it just takes the denominator out, but then we need to times by x plus 2. On the right hand side here, we've got 1. When we multiply 1 by 3 minus x, we get, well, 3 minus x. But when we multiply by x plus 2, it just cancels with the x plus 2 on the bottom. So that's what we've got, and we now just need to expand out here. So we've got 2x squared plus 4x, and this side we've just got 3 minus x. So again, we're going to use that principle of just gathering everything up so that it equals 0. So we're going to increase both sides by x first. Let me do that. So we will have a 2x squared add 5x, and at the same time we're going to subtract 3 from both sides. So we've got 2x squared plus 5x minus 3. So we're almost there. If this does factorise over the integers, it will do so like this. And 3 is prime, so we've only really got 1 and 3. The question is, which one of those would you like to be multiplied by the 2. And of course, given that we want to get to, well, we want to get to 5x, but we want to get to a positive 5x. I think the signs will have to be different. If we position a positive 3 there, we've gone too far. We've gone all the way up to a 6x. But then if we put a negative 1 there, we take the 1 back. So we're now back to a plus 5x. And it does give us the negative 3. So either x equals a half or x equals negative 3. Okay, so that's the last example I'm going to go through today. There were actually some difficult questions there. The last two in particular were very difficult. Because this topic is on GCSE as well, I just wanted to go through some worst case scenarios with you. What I suggest you do now is find some questions that are similar and just get plenty of practice.